This set of videos will repeat the key points from the webinar on Wednesday. We'll start with the idea of UI layout design in Android. So here I have a newly created project just from scratch with all the default options selected inside the wizard. So this is the structure of the Android project. Let's briefly go over it. So in the Java folder, we have a bunch of source code files. By default, we have only the main activity files, but as we start to develop more complicated applications, more and more files will start to appear inside the directory. We'll also try to introduce a subdirectory structure so that not all files are inside a single package. There are some packages, some folders for tests. They're not part of this course, but they allow to implement the testing on the fly as the application is developed, and these tests can be executed automatically by IDEs. The second important folder for us is the res folder. It contains a number of things related to layout design, that is layout and drawable folders, as well as bitmap. And there are also some strings related to defining constants as colors, strings, styles, and some other things in XML files, which help to avoid hard coding them inside the code files. The most important part, however, will be the layouts. By default, here we have an activity main XML file, which is in fact the central part of the first section. That is how we design this XML file so that it represents the appearance of the main screen of the app. Finally, there is also a manifest. A manifest is the general description of the application. It contains some more high-level details like the name, the label, the theme. Here we'll also insert some features of the applications. For example, permissions that our application demands from the user operating system, that the user has to grant our application for it to execute all the actions required. But let's at first go to main activity, to activity main XML. The file on the hard disk is the actual text file. If you switch to the text tab here, you'll actually see what's inside this file. This is what we name the layout. The layout basically determines the visual appearance of a certain screen. So the activity is one screen of your application, and here we have just one single main one. By default, it shows a static text "Hello World" in its very center. So here we can zoom in and take a look at it. And then the main idea behind designing the activity is to place UI controls, which either exist inside the palette here, or we can actually define them right here inside the XML, and they will be placed inside the corresponding preview window on the right. So this is a preview window. This is not yet our emulator. This is just the approximate view of how UI design would look like when you run it on a certain device. So here you can actually choose between a number of options here: the app theme, the type of device, the screen layout, screen orientation, the portrait or landscape for the preview, so you get the immediate glance of what your design will look like on a real device. Let's dive into this layout. So on all the latest Android versions, UI elements are placed in the so-called constraint layout, which allows you to define placement of elements in relation to other elements and in relation to parent. So let's take a look at this text view. All of its anchors, all its borders are defined in relation to parent. As text view resides straight away inside the constraint layout, this is its parent, so we can sort of assume that the parent of this text view is the activity itself in a simplified way. So this, for example, constraint bottom to bottom up means that the bottom border of our text block will be aligned to the, or kind of be constrained by the bottom border of parent. Now this, as you can see, doesn't mean that really the element will be at the very bottom here. It's just we kind of make this association between the bottom border of our element and the bottom border of the screen in this case. Now this will actually play together with the layout width and layout height, depending on what we set them with. Now the width and height have two main kind of special values. which are rep content, which stands for defining the element size in the corresponding direction, either horizontal in case of width and vertical in case of height, as the minimum required space. So for instance, this text block will be shrink to its minimal size in both directions, in both vertical and horizontal dimensions. So as you can see, the actual rectangle of this element is really as small as it can get. Let's change layout width to match parent, the other commonly used constraint, and now we can see that the size of this kind of virtual rectangle that limits our text view is now aligned with the two vertical borders, the left one and the right one of the screen. In this particular case, the left and right constraint are not that important. They will be important in some other cases. So let's try to play with this element further on. Let's define another commonly used control, edit text. Again, notice as we start typing things inside the XML, Android Studio will automatically fill the required things for us, and then we can just define values from the combo boxes, from the drop-down lists. So let's define the width to match parent and the height to rep content. So notice by default this edit text resides at the top of the window. Let's define the hint. For example, we expect the city to be entered in this text block, in this edit text to be precise. And we can also define a special property for edit text input type. This will determine the appearance of the keyboard on the phone screen. So for example, if you just expect the number, then it's better to limit this text, edit text, with numeric input only. Sign, decimal, password, text can be autocomplete. That's basically supports some input lists. So there are actually many different types of things. So the keyword is more appropriate for the specified target, for the specified input type. So let's just select text as the default here. And let's try to play with these constraints. So by default it's at the bottom, at the top, sorry, there. Let's try to put it at the very bottom. So let's put it bottom to bottom of parent. Notice that this now puts the edit text to the bottom part of my screen. Now, how is it different from the text view? Why is the text view in the center, whereas the edit text is the bottom? Well, the reason is that the text view defines both constraints to the top and the bottom. If we do the same thing for our edit text, then the edit text will also stay in the center, so it will be somewhere intersecting with the text view. Now, certainly constraint layout is much more flexible than that. One particular reason behind this is that it allows to define constraints in relation to other elements, not only to the parent containers. And to do this, we have to define a special property that will have its other significant meaning when we start to interface these elements from code. The property is called Android ID. The most common way we do it is create a new ID right here inside the layout. So let's name this text hello. And let's also define the ID for edit text, Android ID, which will be edit city. Just looking a little bit ahead, when this edit text will be used to input the city. So let's now define the constraint of this edit text in relation to text view. So let's say we can let's put it right after the hello world text view. So right underneath it. So we'll say that the top constraint of the edit text will be aligned with the bottom of text hello. And so now these two are kind of glued together. So one goes straight after the other. Now what happens if we also define the bottom constraint to parent? Now this is actually very interesting, that now we'll actually split this half of the screen in two parts, and the edit text will be aligned right in the center of this lower half, or not really half, but the space from the bottom border of the hello world text view and the bottom border of the screen. And so the edit text is right in the middle. So that's how these constraints play together. Finally, let's define a button, probably the third most commonly used control. I'll place both width and height to wrap content. Let's say assign text to search. And let's, for example, put it before the hello world text view. So we can align its bottom border to top of text hello. Notice, however, it's on the left of the screen. To put it in the center or to the right, we also have to assign the left and right constraints. So for instance, if we take both the left and right here, so having the width set to wrap content, this will put the button in the middle. All right, so let's now add one additional possibility. That is defining the width or height, or we define width in this case with a 0 density independent pixels. Now, it's also possible to define width and height in absolute units. For example, we can define the width, let's say, to 100 pixels, but pixels are rarely used because pixels avoid the kind of the screen dot units. And if we leave the size in pixels, the element will look differently depending on how on what kind of screen you have, because screens of the same size may have different densities. So for example, if you take 5 centimeters of the physical screen, depending on the pixel density of how many pixels per inch or per centimeter you have on the screen, the button will look differently. The button will look extremely large on a low density screen, and it may look kind of very small opposite on the high density screen. So instead of defining things in pixels, we define things in density independent pixels. So this will put the size of this button independently of the screen characteristics. But again, this is a hard definition of the size. So in this case, we'll kind of try to avoid it as much as possible. That's why we try to stick with these constraints, match parent and wrap content, so that sizes are defined in relation to other elements. Now, what if we do the following? What if we want to put two buttons kind of close to each other? Well, there are a number of ways to do this, and I'll show you one possibility. We can define the width and height of each button to 0 dp. So let me add another one here. Let's name it search 2. So at the moment they are overlapping. So let me define the right constraint of the second button to align it with the right of parent. So at least now the buttons are spread across. But how do we now kind of glue the borders to the middle? Well, here we can kind of place themselves in relation to each other. So both of them should have their IDs. Let's say plus ID button 1, and this second one will have an Android ID button 2. Again, plus ID means creating a new ID, button 2. Now say that the left constraint, I'm pressing Control Space to show all the list of options available. So align the left constraint to right, so that's my button 2. So align its left border with the right border of the first one. So left goes to right of button 1. So have 0 dp here, have 0 dp here. So notice that the first button doesn't have constraints defined. So basically, it's left in the well, not its minimal size, but it's kind of left with its default size here. And if we do the same thing for the first button, namely we'll align its right border to the left of button 2. So now this will actually glue them together. And we'll also do here the same for left to left of parent. So now this aligns them with the kind of evenly across the screen, so that it makes them into sort of a chain here. And so both of them occupy equal space. I don't think, by the way, this was required, because we already defined this new identifier right here. So the new Android versions allow to define this without the plus here when we're kind of cross-referencing things. So let's apply the same approach and place the button right, the two buttons, let's say to the right of this edit text. So that will go like this. So we'll now assign them to wrap content, the width of these buttons. So now my left button will go to the right of edit city, and the edit city should have the 0 dp width, otherwise it won't play any role here. Its left constraint should be aligned to the left of parent, so it's go to the left of the screen. And now let's place the buttons accordingly. So let's, by the way, align them all to the top of the screen. So I just want to show the different possibilities here. So the top will be to top of parent. So I do it for all of the buttons. Okay, I'll do it like this. So now what I want to do with these is to really put the buttons to the right and leave as much space for the edit text as possible. So the other constraint that I think I have missing here is the constraint right of the edit text to left of button 1. So that will do exactly the thing that I wanted. So let's switch the orientation to check how this goes in landscape. Now notice that these two are minimized horizontally, so they occupy the minimal required space, whereas the edit text is maximized but is not overlapping with this button, because its right border is limited by the left border of the first button. So here is a set of main capabilities that constraint layout allows you to define. The official Android resource also contains some additional things you can define on constraint layout. It's quite powerful, really. It now overshadows overshadowed completely the previous types of layout, like linear and relative layout that exists for a long time in Android. So almost all interfaces can be designed in a flexible way, in a flexible manner, using constraint layout. So that is really the preferred way to go.